Good evening to all. So here we are going to present our PPT on the topic MOS modeling, on which we have prepared our research paper. So the topic of research paper which we have prepared is MOS modeling. This is the content of the PPT that we are going to discuss here. Uh, this is the content of the research paper that we have put together and on what we have researched. First, I would like to explain the abstract, that what in this research paper we have researched about and how we are going to deal about it. So basically, this whole research paper is about MOS modeling, and we have tried to explain the impact and the compact of the MOSFET model for the process variability and also for the awareness of the VLSI circuit design using a systematic design. Actually, using this circuit, using this study, we want to develop and present a compact VLSI model with an integral thermal noise model as well, and this technique would be used for analyzing the impact of thermal noise on the performance of error rate of digital circuits. This was the abstract, and coming towards the keyword that you will be finding in our research paper is noted below. And next introduction will be explained by Harsh Kumar.
So good evening to all of you. So in introduction part, in the design of VLSI circuit using modern CMOS technology, regular downsizing of MOSFET device performance variability caused by process of variability has become the major challenges. In VLSI device circuits and chips, and process variability has had a significant impact on the latency and powers variability. The advancement of MOS IC design has progressed on two fronts in recent years. Improvement in fabrications have been enables the introduction of LSI and VLSI digital system, and on other hand, the emergence of analog MOS circuit technique has allowed the single chip integrations of high performance analog and digital circuit, like analog and digital to converter and digital to analog converter is possible in that thing. And compact model play a crucial role in design of integrated circuit and production manufacturing. Next will be explained by Shivam.
So basically, the our topic is MOSFET modeling, and the working principle of our topic is basically the MOS transistor begin a majority carrier device transports current between its source and drain. A constant voltage is provided to the gate of the relevant MOS to regulate this transistor. Electrons are the predominant carrier in a NMOS transistor, where the host of majority carrier in a PMOS transistor. To learn about the attributes or behavior of MOS transistor and isolate MOS structure with a gate and body is analyzed. The image below show the sample MOS structure basically, and the conductor makes up the top layer of the MOS structure. This is the excellent for the carrying current for any charges, and it is commonly reflected up to our gate. Metal gates were employed in the first transistor, but the time proceeds and the transistor gate will be changed to the polysilicon and a thin integrated film of the silicon oxide from the intermediate mid layer of the MOS, which is commonly referred to as a gate oxide, and silicon is dropped in the layer at the lower level. When we supply a negative voltage to a gate, it proceeds a negative charge as the mobility carrier and charge with the energy outside the gate and the holes. So next topic explained by Ranveer Kumar.
I am going to explain a method of MOS modeling. In here we have taken 4 points. In first point, schematic style of planned MCAM victimization CMOS transistors. And second point is performance verification of the on the top of the for various parameters. And third point is a CMOS layout for the planned MCAM victimization of the VLSI backend and verification of CMOS layout and parameter testing. And next topic is explained by us.
So if we're talking about MOS modeling, application of MOS modeling. So in a MOS modeling, we can use the application we use in that is to use the amplifier or a switch electronic signal by changing the conductivity with amount of applied voltage. And in digital analog circuit, we are also using in modeling, just like MOSFET is most popular semiconductor in device, you know that. And it is and third point is that it is a foundation of modern electronics with transistors being utilized in both digital and analog circuit. And fourth is that digital communication systems, like if you play a video games and a pocket calculator, if we using pocket calculator or digital which was all the example of MOS model. And the fifth one is that computer processor and semiconductor memories and image sensor and most of other forms of integrated circuit use them as their fundamental component in MOS modeling, the use of MOSFET. And last and least point is that switch mode power supply and variable frequency drive and other power electronics application where each device may be switching thousands of watts are the common place in MOS modeling. So these are the basic applications of MOS modeling. And second was, if you're talking about future scope of that MOS modeling concept given in a thesis of USG GODZ MOSFET can be used in a various non-classical MOSFET architecture based on USJ, such as junction-less filled effect transistors, what we call it JFET, and tunnel filled effect transistor, what we call it TFET, and ring MOSFET, and so on. So many other things are there. For and second point is that in future scope we use for short channel USJ based gate underlap and GA MOSFET architectures with both resist S&D and raise the S&D features and continuous drain current model valid in all the regmes of the device operation can be carried out. And third point is that the short channel USJ based on elevated source drain and gate underlap DG and GAA MOSFET architecture and can be studied in analog and radio frequency. That's the future scope of MOS modeling. Next topic will be explained by Aman Sinha.
Now we are talking about conclusion. So basically, as I told that in this research paper, we have talked about the MOS modeling only, and we have, as my members explain about the various topics, that how the methodologies, that how the principles are. So basically the CMOS transistor modeling is introduced in this study. We can summarize this point. Also the characteristic of N channel and P channel MOS devices are dissipated, and together with this information on the maximum current, its relationship has been explained here. Also what we call the Scotch key, thus that the single device. This was as a result of the behavior of whole circuit, and these are the references that we have used, and we have studied all the research paper, and after studying, we have come to this conclusion and this research paper. And this is the screenshot of the acceptance letter in which we have applied for the publication for the research paper. This is the acceptance letter. As you can see, the four authors are mentioned here. This is a screenshot of reviewers' comment that we have got from them, and our publication is still in process. And this is the plagiarism report that we have got from them. It's 100% unique, that we have written the whole research paper with our own. And this is the group's members' contribution. As you can see that Harsh Kumar, Shivam Prakash, Ranveer Kumar, and me, Aman Sinha. Thank you. Also, I would like to show the research paper that we have made. This is the research paper. It covers 4 pages, and as you can see that we have followed the whole format of the IEEE format. And as you can see, figure has been added too, and this is the VI characteristic, application part, future scope, and references. So this is the whole research paper. Thank you.